right, I think we can kick things off here. Thanks everyone for making the time. I just want to give the Giza team a quick introduction and the call here. So today is February 14th, 2024. Happy Valentine's Day, everyone. This is the Gnosis AI call. So each month we host a team building AI applications on Gnosis Chain for a product demo. And today we're super excited to host Giza. So Giza is actionable AI for decentralized applications. Giza builds reliable, scalable, and easy to integrate AI solutions for Web3. The team recently introduced the Actions SDK, a Python toolkit designed to enable seamless integration of ML into Web3 workflows. With Actions SDK, developing ZK-ML workflows becomes very intuitive and streamlined, and you can simply import the Actions SDK Python library and create your workflows. Actions SDK is live, and let me just share the link here where you can access it right there. And following the product announcement of the Actions SDK, Giza announced the Gizathon. And let me share that tweet. It's a hackathon that's ongoing. So yeah, join the Giza team and hack, build ML use cases for Web3 with the Giza suite of tools, AI Actions SDK, and the Giza datasets and Orion. It's a $10,000 prize pool. It runs from the 19th of February to the 26th, and you can register here and find more details right here. And with that, I'm gonna hand it over to the Giza team, and they're gonna run a product demo. So thank you so much, everyone, for making the time. And yeah, go ahead and share your screen.
Thank you very much. First of all, let me just share my screen. If you don't mind, I would like to quickly introduce myself, and also my colleague can do the same. My name is Agatha Shab. I live in Madrid for the last 2 months at least, and I'm a data scientist in Giza. I am also a master's degree computer scientist in Technische Universität Berlin, the Technical University of Berlin. So we're actually quite close. Well, first of all, maybe Jakub, you would also like to introduce yourself.
Sure. Hi, guys. So, first of all, thanks for having us here. My name is Jakob, as Ege already said. I'm also a data scientist by training. I spent a couple of years working in data science and ML in Web 2 and jumped on the crypto train, like two years ago. And yeah, I've been at Giza for a couple of months now. And yeah, excited to show you what we've been building at Giza.
Thank you, Jakob. So before we delve deeper into Giza and what we do, I would first try to at least give like an introduction of what zkML is. And to do that, first of all, I would like to give my understanding or explain my understanding of what ML is, because obviously it's quite a popular topic nowadays, and there are a lot of different ways to define and talk about it. But when we talk about zkML, I think it's important to look at ML from a very low level point of view, and with which I mean looking at it at basically as a transformation pipeline or a chain of operations, usually executed on a very big mattress, basically, or a tensor or some type of data. The way or the reason I talk about it in this way is because zkML is not so different than zk on its own, in the sense that none of the operations that are happening in a zkML circuit are operations that don't happen in zk. The difference of zkML is that usually those operations are executed on really huge matrices. So in order to create a sort of like a successful zkML circuit or a system, basically, you need to optimize a lot of different things. One analogy I like to think about is is the difference between a CPU and a GPU. They are both able to do sort of similar things, but GPU is much better for machine learning simply because it's able to do a lot of computing in parallel. Now, coming to Giza, what we intend to do is basically position ourselves as an end-to-end platform for everything ZKML. This means not only the ZKML libraries and frameworks, but also the deployment, the integration, the development of the models, etc. So in order to explain what we do component-wise, I would like to share, first of all, this picture, which is basically all the 5 important components in our system. Talking about it from a chronological order, I would first start with the datasets, which is basically a collection of datasets that we have created using different data collection sources. Those include RPC nodes, those include big aggregators and everything in between. And this also is served through an SDK. So you're basically able to use or load any data you want from our library in your Python environment without any hassle. Then I guess we can talk about Orion, which is our open source ZKML framework. Currently, it's based or it's written on Cairo, but there are sort of different versions of it that will be written on EZKL and other popular ZKML frameworks. Obviously, ZKML on its own is a relatively emerging sort of science. So a lot of technologies are competing right now, and it's not so really certain which will be the best one, which is why we decided to be as flexible as possible and integrate all the ZKML frameworks that we deem as working. After Orion, I guess chronologically, the next one would be the platform or the Actions SDK, which is basically the way I would sort of distinguish them is the CLI and the Actions SDK. And these are basically tools that are also, you can run easily in Python, where the idea is that you can use those tools to first transpile the models from either PyTorch or TensorFlow or whatever popular ML framework you want to provable models, and then deploy these models in our GCS, in our cloud server, so that you can basically create an endpoint for anyone to run inference on these provable models, as well as do other things such as ask for the proofs of the inferences and also verify the proofs. And after some time, we're obviously also going to integrate the platform with the blockchain itself, which will be done through the Actions account abstractions, which is the last component. And through that, you would be able to use the output of the inferences from these verifiable models in any of the smart contracts that you would like to build, which would make them, in quotation marks, smart, which is something that we're actually really excited about. This is, I guess, more of a topology of our components. Not much I can add other than, as you can see here, I'm going to emphasize again, we really make sure to be as flexible as possible with the technologies that we use or the underlying sort of infrastructure that we selected, to make it suitable for any purpose, from enterprise to personal use or just to have fun, just to play with the tools, etc. So, whatever your sort of goal is, I think there's an option within our platform to build it. After that, I'm going to hand it over to Jakub to go over a bit more in detail about the specific components that I just introduced.
Awesome. Thanks for that intro, Ega. And yeah, let me share my screen now.
Yes.
I think you guys should be able to see it now. Cool. So what I want to do here is to kind of go through each of those components that Ega described and kind of so like first go through the docs, so that we can get a better feel for what actually those tools are and how to use them. So starting with the Giza datasets, as Ege already said, this is kind of, you can think of it as kind of a hugging face for everything ZKML, especially within the blockchain Web3 crypto space. So what we did here is what we envisioned Giza datasets to be is basically one place that you go to for all of your data that you might need for ZKML use cases within crypto. And naturally, as with any Python project, there's a couple of ways to install it, be it either with pip install as usually, or with the source by cloning our repository. I'll send over all of the links that I'm discussing so you can have access to the GitHub and to the docs as well. And yeah, using the data sets is as simple as importing from Giza datasets, importing the relevant objects that you might want to use. Two of the most prominent ones are the datasets hub and datasets loader. The datasets hub allows you to explore the datasets that we have. So you can do a couple of different things with it. First, you might be interested in a certain category of applications. In that case, you could search for all of the different data sets with given tags. Let's say you might be interested in DeFi in particular, or like one protocol in specific. Then you could first view all of those tags of the different data sets and then get all of the data sets by a given tag, like shown in this example here. And loading a dataset, for that we use the dataset loader object, and it's as simple as initializing the dataset's loader object and then loading with the given name. So like as you could see here, while you're like exploring all of the datasets, you're gonna get the name of the dataset here, right? And that name is basically what you use to load the dataset. Like on the back end, we're using pollers, so it's kind of a more efficient take on pandas. So probably all of the data scientists and ML engineers here are well familiar with pandas. Pollers, for those of you who are not familiar with it, it's basically a slightly more like a more performant version of pandas, but you can do all of the pretty much the exact same things with it, and the syntax is very similar. You can also naturally just like load it with the dataset loader and then turn it into pandas if you prefer to work with pandas rather than pollers. Yeah, and as Ege mentioned as well, we have a couple of different datasets already. We're working continuously on adding new datasets, but what you can access for now is a couple of aggregated datasets, how we call them. So things such as TVL, the prices, APYs, market cap for different tokens and protocols where applicable, and then there's a couple of protocol specific data sets. So yeah, for to begin with, we took the most interesting, the biggest protocols that are there in DeFi, such as Aave, Balancer, Compound, Uniswap, Yarn. And yeah, you can access some data from those protocols directly from with the Giza datasets. So if you were designing an actual ZKML solution, that would be probably a place where you would start to fetch your data. Then after fetching the data, naturally you would do all of the processing with it, preparation, splitting into train and test set. And for that, we envision people should use the Giza Actions SDK. So what Actions allow you to do is to basically create the entire machine learning workflow from fetching the data through all of the preprocessing all the way up to inference, all within a Python environment. And then on top of that, after the successful deployment and inference, also making those inferences verifiable. So with Giza actions, naturally you would install it in a similar way, also either from pip install or building from the source by cloning our GitHub repo. And yeah, I think like two main concepts to use. So if you want to, maybe before that, if you want to use the Giza Actions SDK, you're also going to need the Giza CLI. So you will have to install with pipx. I'm going to talk about the Giza CLI in a second and more details as well. But yeah, essentially you would install the dependencies from that library, then either create a user if this is your first time using the CLI, or just log into to your with your credentials. And every user of Giza has their own workspace where you can manage all of the models, all of their versions, create deployments, manage them, create and run inferences, etc., etc. Yes, and this, as I said, I'm going to send the links in a second, but there are a couple of end-to-end examples that you can follow. So the main idea with the data with the Actions SDK is it revolves around tasks and actions. Let me scroll to show you an example of an action. So task would cleaning it, pre-processing, splitting into a train and test set, converting into the ONNX model, all of that. And then you can kind of wrap a couple of those, as many as you want of those tasks into one single action that you can deploy and execute. So what it does is takes care of the entire pipeline that you have defined with tasks, all within one action object. Yes. So one maybe to give you a bit of a better idea of how the entire workflow would look like. Actually, maybe I'll leave it for later to show like a full end-to-end example. We can talk about Orion now, which is another part of the Giza stack that Ege mentioned. So Orion is essentially used it's a ZKML, it's an open source ZKML framework. And what it allows you to do is to take your ONNX models and transpile them into ZK circuits, so that you can run verifiable inference on them. And Orion is built in a very modular and extensible way. And as a proof of that, we support multiple proving frameworks, such as Ezekiel, for example. So if you're used to, for example, using Ezekiel, you can do that through Giza Orion as well. Yes, and finally the CLI, which is a CLI is kind of like a terminal-based tool for managing your entire Giza stack. So you can manage all of your models, create new versions with it. You can transpile models using the Giza CLI. With the installation, similarly to previous projects, you can install it with pip, with pipx, or directly from the source. You would typically, as a first step, create an account. So with Giza users, first you would create an account, or if you have an existing one, then you would log in at the beginning of your of working with the Giza CLI. A cool thing with from the CLI is that it allows you to easily manage all of your different models. So if you're working on, let's say, even one use case, but you might have multiple different versions of a model, right? Because you're iterating constantly, trying to come up with as good of a model as possible. Giza allows you to do that. So you could have one model for a specific purpose, but each of those models will have a different, like each model might have multiple versions. And versions could be, like the same model as in like the same algorithm trained on slightly different data or just trained on fresher data, but it could just be a different underlying algorithm. So you could have a model for predicting whatever interest rate on a lending protocol. And then you could have, a neural network, you could have an XGBoost model, you could have whatever, a linear regression, whatever you want, and all of those could be a different version within that particular model. And what it allows you to do is to easily keep track of what models you have, and also like keep track of which models are running on production. Right, so this is the versions part, and yeah, I alluded to workspaces earlier. So yeah, it kind of allows you to track everything from within one space, all of your deployments, all of the actions, all of the inferences. And once you have your model ready, after most likely using Giza actions and compiling it into for example, a Sierra file, you could run it with, you could deploy it with Giza deployments, like in this example here. And with that, you can then run inference, for example, an API, also Giza API. So yeah, this entire stack is, I think, very flexible yet powerful in the way that you can take whatever framework, whatever machine learning framework you're used to, be it PyTorch, sklearn, TensorFlow, or whatever, and turn those models into production-ready, verifiable zero-knowledge machine learning solutions. Cool. So now let me show you a kind of end-to-end example of how actions can be used. So this is an example of predicting the utilization rate on the compound V2. In this particular case, we're focusing on predicting USDC utilization rate. For those of you who are not familiar with lending markets, utilization rate is defined as the total sum of borrowed tokens divided by the total sum of supplied tokens in a given market. So, for example, the USDC market has 1 million supplied, but only 400,000 is borrowed from that market. This market's utilization rate would be 0.4. And there could be multiple reasons for why that would be an interesting thing to predict. One could be protocol trying to always maintain a sufficient liquidity for all of their users to be able to close their positions, or redistributing the liquidity across different chains if a protocol is on multiple chains, such that they can optimize for the fees, or provide sufficient liquidity on each of those markets. So in order to go through this end-to-end ZKML example, you will need to install all of the parts of the Giza stack, so the CLI, the data sets, the actions. As discussed previously, you would first need to log into the Giza CLI, create a workspace, or get the existing one, and the same with the model. Either create it or use a current model and the current version of it. For this project, we took 4 different data sets from the Giza dataset stack. These are the compound daily interest rates, the APYs for different protocols, TVLs for different projects and tokens, and finally, token-specific data such as their prices, market cap, or volume on a given day. As shown before, loading a dataset is as simple as initializing the dataset's loader and then loading it with loader.load command. I don't want to go into the details of all of the pre-processing because it's kind of specific to a given project that you're working on. So probably going through it here doesn't give a lot of value. But after you have defined all of your steps of the pipeline, you could also wrap them within the tasks. After that, you can wrap all of them in one big load and process task from Giza Actions, which you can then use within the final action to go do all of the processing, data loading and processing steps, like within one line of code executed. So assuming we have all of our processing done and we have a data frame with the independent and dependent variables prepared, we can create a simple neural network model with PyTorch. This model can be much bigger. Currently, there are some restrictions around the model sizes. So if your model is too large, if you wanted to run verifiable ML on something like Llama from Facebook with 7 billion parameters or more, you probably won't be able to. But smaller neural nets that should be valuable in production are very much possible. So yeah, as you can see in this code example, we have defined a neural network architecture. We have all of our tasks prepared for splitting the data into train and test set, training the model, and finally exporting it into ONNX file. And finally, after all of our preprocessing and training is defined, we can create one big action and deploy it with a couple of lines of code, which I think is pretty neat and useful. As such, I don't think it makes sense to describe like each line of code here, but yeah, you can see what's happening. And finally, after you have your model deployed, you will need to transpile it. If your model is directly compatible with the current transpiler version, you don't have to transpile it manually. But if, for example, there's a new operator that you have used, or for some reason the model you have used is not yet compatible with the transpiler, you can do it manually with the Giza CLI. So from the Giza CLI, you would run the transpile command, passing the path to your serialized ONNX model, and providing the output path for where your transpiled model should be saved. After that, you would build this Cairo project with your model, and as a result, you should get an inference.sierra file. And as a next step, you can deploy this model with also the Giza CLI, with Giza deployments deploy. You provide the version of your model, the ID of your model and the ID of your version, of that model's version, and finally the path to your inference.sierra file that we got from the previous transpilation step. And finally, once this is done successfully, you can run inference on that deployed model in two ways. First, you can do it in kind of a traditional machine learning way, right, without any ZK proofs, without a formal verification of its inference. Here's a code snippet of how to achieve it. As you can see, we're following a similar convention. So like first we're defining a task that defines how the prediction should happen, or like if there are any pre-processing steps needed, we would add them here as well. And then finally creating an execution action that runs our prediction, our inference on that deployed model. Similarly, we can run a verifiable inference. For that, you will need to provide the model ID and the version ID. And everything that changes technically is in your predict. When you're calling the .predict function on your model instance, you pass verifiable equals true as an input. And what it's going to do is run the verifiable inference and save the proof. And then you can fetch that proof and download it locally with our API. And here is also a code snippet that shows how to do it. Finally, once you have your ZK proof downloaded, you can verify it also using the Giza CLI with one simple command, such as here. Yeah, so I think that's all I wanted to show you in terms of how to use the entire stack together. And with that, I'm gonna hand it over to Ega, and I will share all of the relevant links in the chat.
Thanks a lot, Jacob. I know that we don't have a lot of time, so I was told that there was also some interest for the Circles UBI, sort of like a network analysis report that we have made, I guess, 4 or 5 months ago. I know that we don't have a lot of time, so I'm sure, like, I just sent the link to the chat. I guess we can take the questions right now, but if anyone has any questions regarding the network analysis report, I would love to answer. Or any other questions regarding the Giza platform, obviously.
Hey. Hello. Can you hear me?
Yes, we can.
Okay, so I am David, and I am the community growth manager for Darwinia Network. So a bit of what we do is we help power dApps cross-chain capabilities, you understand? That means having a dApp on Darwinia means that you could have virtually access to multiple chains, you understand? So I wanted to know how can a technology like Darwinia utilize this recent Giza Tech solution, which is on board? Like, could you just give me a basic walkthrough on how it can be integrated into our technology stack?
So I'm obviously not. I don't know the intricacies of your technology, but basically any sort of dApp or cross-chain dApp could essentially utilize the verifiability of the inferences and basically have models that are positioned off-chain, but utilize their inferences on-chain, which means that rather than, execution inferences in models, which are obviously very expensive, especially if the models are large in size, you can leverage the verifiability of the model to basically utilize the machine learning capabilities of these models without costing too much. So you can technically have smart contracts or smart dApps that use machine learning. That being said, obviously, I don't know, your specific solution in detail. So I guess that's all I can say.
Okay, that sounds great. I mean, we are looking to onboard better apps, you understand, on the network, and of course, machine learning could be of useful addition to us. So, I'm just new to the Gnosis chain ecosystem, you understand. I just joined the Discord server because I saw about this event on X, and I loved the idea behind the event. So I'll probably want to keep touch from time to time and ask a couple questions on how we could do something together, I mean,
Absolutely. I think you have our Discord channel as well. You can contact us directly through the Discord, and we'd love to have a talk. Any other questions?
Yeah, I have a quick question. It's more high level, but can you just talk about why ZK technology is a good fit for machine learning? Like why are those two things? Why do they go together?
Um, I think there are sort of different possible answers to that. If we're going to talk mainly about the blockchain, the reason would be that there is a very high asymmetry between the computational costs off-chain and on-chain, right? Like it's any computation that you would run in a cloud server, etc., is much cheaper than the same computation run in Ethereum or even L2s. In that sense, ZK is obviously really helpful because ZK is, in my opinion, the only way to realistically enable machine learning capabilities on chain. Because given the sort of like the overview of the decrease of computational costs, by using L2s and other tricks, etc., there's obviously a decline there, which is very hopeful. However, machine learning, especially the large sort of LLMs, etc., that are really popular today, are so big that it seems unfeasible to think that you would ever have a LLM inference run on chain, locally. So I believe ZK is the only sort of realistic approach to enable that.
Yeah, if I can add to it, I think there are some use cases that very much naturally suits the combination of ZK and ML, and that don't necessarily come from the fact that as
Sorry, say that again.
graphically proving that a certain model was run without revealing the weight of that model, let's say. So like if you're a developer working with OpenAI and you use their API to send some requests, and let's say you're requesting GPT-4 or like whatever the latest model would be at a given time to get your results from. They give you something, they give you some response, but you essentially have no way of knowing that this particular model that you have requested and most likely paid for premium was actually run. Right, all best you can do is just like trust that OpenAI is giving you the version of the model that you're paying for, but you have no real way of checking. With ZKML, you can do it. You can have a cryptographic proof that this particular model that you have requested to get your inference run on was used to produce that particular result, given the data that you've given them. Another example is you can flip this scenario on its head. So like, let's say that there's a public model out there, but you want to keep your data private. So like you want to prove to someone that you have run inference on that public model using your private data because you might have some sensitive data or any personally identifiable information that you're not comfortable sharing with that third party that provides the model. And with ZKML, you can prove that you run that particular public model on your private data, and this is the output that you got out of it. So then, that the third party that you're interacting with has a cryptographic proof that there was a correct execution, but they know nothing about your personal data that you used to get this result. Yes, and naturally, like both of these use cases are kind of hypothetical right now in terms of, for example, with OpenAI, the LLMs are way too large to actually run verifiable inference on them. But it's a very new technology, like the entire ZKML field. So not more than a few years ago at most, right? And it's the performance of those models and what we can do, like what sorts of models and sizes of models that we can run verifiable inference on is increasing dramatically over time. So yeah, like those are hypotheticals for now, but I don't think they're very far from the reality.
Cool, thanks. Yeah. So for like your everyday user, like, excuse me, someone who may not be like a coder or very technical, maybe they just, they use a smartphone. Like in the future, do you see ZKLM having the ability to provide everyday users with like a higher level of agency with the fact that ZKLM offers a level of privacy to everyday users, like, but how would they interact with ZKLM to say, hey, I want to keep this private, or I want to protect myself against AI. Do you think ZKLM will be a solution to something like that?
Yeah, I think so. Like, yeah, again, like this is kind of a hypothetical for now because yeah, the tech is just like not there yet. This just like the cryptographic state of the art is just not there yet. But like, it's possible that, for example, in the future, you would require something like proof of humanity to access certain services. And the way you could do it is like running some sort of a facial scan with your phone. But you might not want to give out your facial scans to whatever third party that you're interacting with. With ZKML, you could do it, right? So you could run a local inference on your data and send the proof that like you passed this check of humanity. The ML model verify that you are a human, but your personal data that you used to get this result stays on your phone. I guess with LLMs, you could probably work with some health data, and then a very much like private data, public model setup would be beneficial for everyone included. But yeah, it's like LLMs are probably a couple of years away, like being able to run verifiable inference on big LLMs.
Cool. And what do you think about like the whole decentralized compute field for AI? Do is Giza going to work with decentralized compute protocols in order to access more compute so that developers can build larger applications, or like how do you think about that?
That is actually something that we are having everyday discussions about. For now, it doesn't seem like I guess it doesn't seem like something that will be developed in the next 6 months, just because using AWS or GCS is relatively easier, and our first instinct was to build and publish the software as soon as possible. But obviously, that's, I think, a very interesting topic because making the computational layer decentralized, I think, is the most sort of essential component of any software to decentralize. As we go, deeper and deeper into machine learning, I think it's becoming clear to everyone that compute is what is crucial. It is the bottleneck, and I think using only these very large data cloud providers is obviously not the way to go. I think it's reasonable to wait until one of the many decentralized computation protocols or networks become mature enough for us to very seriously have a look at it. But it's definitely something that we are actively discussing.
Yeah, one thing I'll add to it is if what you're after with decentralized compute is integrity of the computation, right? So like your concern is you don't want to depend on a centralized compute provider like AWS or Google Cloud or whatever, because you're afraid that potentially they might, on the back end do something malicious with your whatever model or like whatever computation you're running. And it's critical for your application to have like a fairly run inference. Then probably decentralized compute is not. I mean, like it solves this problem, but it solves it in a way less efficient way than ZKML the way we're talking about it does, right? Because with ZKML, it doesn't matter if I'm using, like if I'm running the verifiable inference on my local MacBook on AWS or whatever. Like if the output is cryptographically verifiable and I can cryptographically verify the integrity of that computation, like that's what we're after. That's good enough. Probably even better than with decentralized compute.
Cool. Any other questions for the Giza team here? All right. Are there any upcoming events aside from the hackathon that you want to let us all know about, or any conferences?
Miriam, perhaps would you like to talk a bit about?
Yeah, the hackathon, thank you so much. You already actually gave a good overview, John, and shared the link, I believe. But that will be from February 19 to 26. It will be running fully online. And we are speculating some future hackathons for 2024 IRL. So keep on the loop for that through our socials. But in terms of events, Jakub and one of our co-founders, Fran, will be in ETH Denver. So if you'd like to meet, some team members will be there for sure. And you can always come to our Discord and check out on our socials for more grants and hackathons. We'll likely announce more in the upcoming months. And thank you, John, so much for having us.
Yeah, thank you everyone for making the time. It's been great. And if you want to share the link to your Discord in the chat over here, that would be great.
Yes.
And yeah, thank you so much. So we will see you next month for another round of the Gnosis AI call. Typically, it is the second Wednesday of each month. So keep an eye out for that announcement. And have a great month, everyone. Take care, and we'll see you on Chain. Bye-bye.
Thanks for having us, guys. Bye bye.